Welcome to today's lesson on core electrical elements and electrical sources. These fundamental components are the building blocks of electrical circuits. Understanding how resistors, inductors, and capacitors function along with different types of electrical sources is crucial for mastering circuit theory and performing well in competitive exams. Ever wonder how your phone works or your TV? These everyday gadgets are more fascinating than you might think, or even a simple flashlight. These devices might seem simple, but they have a lot doing inside. It's all start with magic of circuits, the pathway that electricity follows. These paths are like the veins in our body, carrying life, giving energy to every part. And just like any cool invention, circuits have their own sets of building blocks, core circuit elements, and electrical sources. Let's start with circuit elements. Every electrical circuit is made up of two types of components. Passive and active. Passive components do not generate energy but can store or dissipate it, while active components can supply energy to the circuit. A resistor is a simple but vital passive element. Its main function is to resist the flow of electric current. When current passes through a resistor, energy is dissipated as heat due to opposition to current flow as described by Ohm's law. Next we have inductor, which is also a passive component, but unlike resistors, inductors store energy in the form of magnetic field. This occurs when current flows through a coil of wire. As the current changes, the magnetic field either expands or collapses, generating an electromotive force that opposes the change in current. This is Faraday's law in action. The induced voltage is proportional to the rate of change of current. The inductor's unit is Henry, and inductive reactance XL in AC circuit is given by 2 pi FL, where F is the frequency of the AC signal. An important concept to remember is that inductors resist change in current, which is why they are commonly used in filters, transformers, and energy storage systems. Now let's move to capacitors, another passive component that stores energy, but in this time in the form of electric field and between two conductive plates. When a voltage is applied across a capacitor, charge accumulates on the plates, creating an electric field that stores the energy. Charge stored in capacitor is given by this formula. Capacitors oppose changes in the voltage, which is why they are frequently used in timing circuits, oscillators, and filtering applications. Additionally, capacitors store and release energy without dissipating it, making them ideal for smoothing out the voltage fluctuation in power supplies. We have talked about the components that manage and shape the electrical current, but what about the components that provide the current in the first place? That's where the electrical source come in. Just like water pump provides the pressure to move the water through the pipes, electrical sources provide the voltage that derives current through a circuit. Electrical source come in two main flavors: independent and dependent source. Independent source like batteries, power outlets provide a constant voltage or current regardless of the circuit they are connected to. Dependent source, on the other hand, are bit more complex. Their output depends on other voltage sources or the current sources of the given circuit. Dependent source controlled energy. In this section, we delve into the fascinating world of dependent source, a crucial concept in electrical engineering that allows for more dynamic and responsive circuit designs. Now, for the more sophisticated member of the source family, dependent source, these sources are not just static, they adapt and change based on the conditions of the circuits, making them incredibly versatile and powerful tools in the hands of an engineer. These sources, like programmable pumps, adjusting their output based on the signals for other parts of the circuits. Imagine having a water pump that can change its flow rate depending upon the needs of different parts of a garden. This is adaptability which makes dependent source so valuable. We have 4 types of dependent source with each unique characteristics and application. Understanding these types, mastering the use of dependent source in the circuit. Initially, the first one is the voltage controlled voltage source, or BCVS. Its output voltage is multiple of another voltage in the circuit, like an amplifier boosting a microphone signal. This type of source is essential in audio equipments where precise amplifications of the signal is required. Next one is current controlled voltage source, or CCVS. Its output voltage is proportional to a current flowing through another part of the circuits. Used in sensors, measuring instruments, this allows accurate measurement and control in various applications, from industrial sensors to the scientific instruments. And the third one is voltage controlled current source, or VCVCS. Its output current is a multiple of another voltage in the circuits, found in the active filters and oscillators. These are crucial in signal processing, where maintaining the integrity of the signal is paramount. And finally, current controlled current source, or CCCS. Its output is the current which is proportional to the current flowing through another part of the circuit, used in the current amplifiers and control systems. These types of source is vital in application where precise current control is necessary, such as in motor control systems. These dependent source might seem a bit complex at first, but they are essential for building more sophisticated circuits that can process signals, amplify power, and perform complex functions. By mastering the use of these sources, engineers can create circuits that are not more efficient but also more capable of handling a wide range of tasks, from simple amplification to complex signal processing. Understanding and utilizing dependent source is a fundamental skill for any aspiring electrical engineering, opening door to innovative and advanced circuit designs. Now let's summarize. Resistors dissipate energy by opposing the current flow. Inductors store energy in magnetic fields and resist change in current. Capacitors store energy in electrical fields and resist change in voltage. Independent source provide constant voltage source or current source, while dependent source adjust their output based on other based upon other variables in the circuits. Understanding these core concepts is essential for solving problems in both AC and DC circuit analysis. As you prepare for your exams, focus on mastering these fundamental principles. They will serve as foundation for more advanced. Hope it will be helpful for you. Thank you. Like, share and subscribe.